Just because the answer is negative 6.
No. All right. 100 divided by 20 is what?
5.
What's 100 divided by 20? 5. What's 10 divided by 2? 5. So if I move the decimal back one place, I've made an equivalent thing. There's no, I don't have to go, oh, I did, no, I didn't. I canceled stuff, right? So the same thing, would anybody in here say that those are different, are those different numbers? Are those different numbers? No. And some of you guys, hopefully, you'll be honest. Some of you guys are going, well, the first got a 3 and a 4, the other one's got a 6 and 8. Well, what's your problem? But what number is this? 3/4 is the number 0.75. What's 6 divided by 8? It's the number 0.75. These are the same damn number, right? So as long as I do the same thing to the top as I do to the bottom, the number remains the same. So if I move the decimal over once and move the decimal over once, I multiply top and bottom by 10, it's still the same number. It's still negative 6. It was negative 6 before. It's still negative 6 now. It's just easier to look at if I kill all the decimals. So you guys understand. You've never... We did a division problem earlier, the 0.09 thing. Is that up here? No. Remember one of the first rounds you did was the 0.09 divided into 4 point whatever it was? You guys with me? And you guys pretend like you're with me?
Yes.
Maybe it was even 0.009, I can't remember. And we moved 1, 2, 3, and we moved this 1, 2, 3, we divided. Nobody at the end of that said, do we have to put the decimal in the other place? No, of course not, because you've made an equivalent problem that looks nicer to work with. Maybe. It's a good question that you have. And I want you to realize I understand why it's weird. But if you know that this is the same as this, and you should know that that is the same, then you should be cool with that, with the one that being the same as this. There's no adjustment. Whatever the answer is to this is the answer to this, because they are the same.
Yes.
Yes.
Yes, because
Multiply top and bottom by 10. So it's the same number. I like it. Okay. Maybe. Okay. What's up? Use your words. What's the matter? That's constructive. All right. Where do you guys want to go now?
now we do one G.
This is the same kind of problem, right? That we did earlier. So again, I don't want to think about 0.021. I'd much rather make this into 21, but the only legal way to do that is if I change this number, better change that number. Which is the same thing as moving this over and moving that over. It's exactly the same. I'm talking exactly the same thing. So if you're cool with what I just did there, you have to be cool with this. You have to, because they're the same thing. So then I got 21 into 640.1. Now when I get that answer, I'm done, right?
Right. That's why you're just putting that right in the same spot, right?
Yeah, exactly. And you're done. Same thing here. If I move that over, when I get that answer, I'm done.
Yeah.
There's nothing to adjust. I like it for the same exact reason. Are you guys cool with this? What's happening? Are you guys all right? What's going on? Are you bummed out? Are you all Chargers fans?
No. Definitely not.
All right. Sorry.
No way.
So now you just start doing 21 into 64. You just start dividing it like normal, right? I can't remember how this one comes out. 21 goes into 64 3 times. Now here, what do I do here? Does 21 go into 10?
No.
So what do I put here?
Zero.
It goes in 0 times. Bring down the 1.
Yeah.
Now 21 goes into 101
Probably
4
4.
times.
Just like that, right?
Let me stop for a second. What's up? Right? Because 21 goes into 10 0 times.
That just doesn't.
Bring down the 1 now. Now 21 goes into 101. Not quite 5 times. 5 times would be 105. Too big. 4 times is
80.
84.
Anybody else? 17.
17. Bring down to 0.
8.
Right? Can you remember, does this one stop eventually?
Does it ever stop?
Oh yeah, no. I was a little evil there. So hopefully you realize you get like 30.48905 and then just this would be 1 on the test. I would say rounded to the nearest thousandths place or something. So if I said round this, let's say hundredths place. If I said rounded to the hundredths place. Good. Well, no. You go 1 more than the hundredths place. That's why I said good at first, because that would be the correct answer. How do you round a number? If to the hundredths place, I have to be able to look to the next place over. So I better make that place exist.
Yeah.
All right.
That way.
So if I go, 21 goes into 178. Good. 8 times 21 is 168.
2. Yeah. 0.
Does 21 go to 20?
It does not. 0.
No. So it doesn't matter what's next. If I round it to the hundredths place, it'll be 30.48 because the next number is a 0. So if I say round it to this place, you've got to go 1 more place out so you have a number to tell whether to go up or stay the same. Do you hit or do you stay? Yes.
I stopped at 3.8.
30.48? Sure. But, you know, like I said, if on the test they say round to the hundredths place, you have to go out to this place so you know whether to go up or stay. I like it. Exactly. 5 or higher, you go up. 4 or lower, you stay. If you get the right answer for the wrong reasons, you will lose points. Of course. The purpose of this class, you're going to be freaked out by this. The purpose of this class is not to get the right answers. Believe it or not. The purpose of this class is to understand the process that you use to get the answers. So if you use the wrong process and end up with the right answer, you will lose points.
Alright.
I love it. Some of you guys hear that and hear me saying, I am mean, I am mean, I am mean, I am mean, I am mean. That's all you hear.
This one, but you probably won't every time.
What?
Right?
What?
So if you went a roundabout way to get the answer and you got it right this time, it probably won't happen every
Exactly. You
time.
might have gotten lucky
Yeah.
this time. So if this would have been a 5, then 30.48 would have been the wrong answer. All right, I like it. So just because you got lucky, sort of like you never wear a seatbelt and you just keep getting lucky and you keep not dying, that's great. But you'd rather wear a seatbelt, just be ready for that one time. That was a little morbid. I don't care.
It takes one time.
That's all it takes. Yes. Oh, okay. So real quick, just to look at like 6B real quick, and then I'll do 6C. I'll make sure if everybody can do 6B, it'll be easier to explain 6C. What can you do here? You don't have to, but what can you do here? Multiply by?
I just see your point.
Yes. Multiply by? 10. Why 10? I like that, James. Like, somebody said 10.
It'll move the decimal out of the way.
Yes, it'll move the decimal out. It'll kill all of your decimals, right?
Okay, it's why.
You don't have to do this, but I kind of like working with whole numbers, and I know math pretty well.
Yeah.
So if I multiply everything by 10, it'll move all the decimals over once. So now I get 14x minus 35 equals 28x. That just looks nicer, right? Well, now you get your x's together. right?
Yeah, why do we multiply by 10?
How many times do I want to move the decimal over so it's no longer a decimal number? Just once, right?
No, it's not.
What do I multiply to move it once? 10. If I want to move it twice, I got to multiply by 100. 3 times 1,000. I like it. The number of times you want to move is the number of zeros in the multiple of 10 that you want to use. Okay. So minus 14, negative 35 equals 14x. Divide by 14, divide by 14. You can reduce that. Okay. The important thing for me was to get that first step understood. Now, if you look at 6c, how does it look different from 6b? Because the mistake people make, if you try to multiply by 10 right now, the mistake people make is they make this 40, and then they make this 11 and this 23. Let me stop right there for a second. Do you guys understand what I mean? So this was easy. Everything's separate. So I just have to move all the decimals over once. Now here, if I move that decimal over, move that decimal over, move that over, make that 30, then people are going to also make this 40, and that is incorrect. Because then you've multiplied this by 100. You multiply the stuff on the inside by a 10, and you multiply the stuff on the outside by a 10, so you multiplied overall by 100, which is too much. So how do you keep from making that mistake? Well, you first just bring that in. And then you have separate terms, just like that problem. This is if you want to do the multiply by 10 thing and move the decimal over. If you don't want to do that, then you just solve it like normal. Right? Yes, sir?
You can multiply 0.5 by 10?
Not yet. But eventually, because it's a decimal. I want to make it not a decimal anymore, right? So what do you get here? 4.4x. No, careful. 23 times 4 is not 812, right? 23 times 4 is 92. Yes, right?
Yeah, that's right.
So 2.3 times 4 is 9.2. You don't make room for the 1, you carry the 1. You guys see that? I'm not picking on you because it's a really common mistake. 4 times 2.3, you can't say it's 8.12, but I see where it came from. That 1, you don't push it over and make room for it. You make the 8 become 9. You carry it over to the 8. Yeah, you do. That's what I just did. Yeah. 23 times 4 is 92. So 2.3 times 4 is 9.2. Okay. So now I can multiply everything by 10 if you want to. Everything has to be multiplied by 10. You don't just say, I'm not going to multiply him because he's not a decimal. You don't have a choice. You can't multiply one side and not the other. Everything must get 10 times bigger. So now this becomes 44x minus 92 minus 5x equals 30. And that should be relatively easy after that. So let me do this. Let me go ahead and give you guys the answer key. Because we get tired of doing stuff that I've already done. Tired of doing stuff I've already done, Jackie. I cannot get tired of math. Oh,
I wish I was on your level.
Yes. That'd be nice. I wish I could push a button and just fall out of the seal. There's one for you in there. Okay. Say again, sorry. The sleeve inside your jacket. Oh, you need this sleeve pulled down? Oh. What's the matter with it? Is it too far up inside? Oh. I don't know if we can get in there, dude. Sorry, bud. Where is it? It's way in there, dude. Does not want to work with me. Oh, I see. It can't go over this thing. Oh, it can't? I know. There it is. That's a little better, right? Let's see. Stuck on something. Oh, I see. It's stuck on the bottom of this thing. There we go. Is that better? It's up there a little bit. It's still stuck on something. Well, that's better, right? What's that? Oh. What happened to you this morning, man?
Somebody pulled my jacket.
Oh, I see. All right, I'm with you.
But they put my sleeve down.
Gotcha. All right, so you know you feel a little more. I know how you feel. All right, guys. So where to next? What do we got? Or you guys are looking over the answer key. So real quick, just make sure you understand. Number one, I put on the back all those just to give it more room, obviously. So if you're like, what the hell's up with this dude? Didn't do number one at all. It's on the back. And number 10F. Did I finish this? 10F, 10G, 10H, 10I. Yay, I did. Yay, Joe.
On the percentages of the poker chips, why do you after like the 26% and 22 and all that, when you got some circle like 0.490?
Yeah, I did 9 divided by 22.
Right, why did you do that? I mean, isn't the answer just 9 over 22?
You could leave it like that, but the idea is to get it closer to being able to say something like about 41%. Because we're used to saying probabilities in terms of percentages. And we haven't gone to percentages yet, but percentages would just be moving the decimal on the decimal number, right?
Right.
So that I could say it's about 41% chance. Right. If the weatherman came on the TV and said there's about 11 out of 70 chance, like what the hell are you talking about? Who are you? Make it into a percentage, right?
Yeah.
Okay. But if you just put 9 over 22 for those, that's fine. I think there's some probability questions in that last section, so I wanted to put a problem like that on there. Alright, how's everything else look there? I will ask you one like number 2, right? Where you have to tell me in words what the decimal is. Yeah.
How about for the 7C? What do you have, the 20 over 15?
No, that's from part F. That's from 6F. It just ran down the side. The answer for 7C is below that, right? Below the image, yeah. It'd be funny if I would just go, because that's the right answer, man. That was for 6F.
But how would you know to
Oh, it's an option. So guys, real quick, just to show you, because I haven't really done one like this, but if you had 1.2x minus 0.4 equals 0.2x, you really don't have to multiply this by 10. If I subtract 0.2x, I get 0 there, negative 0.4. What's 1.2x minus 0.2x?
Yeah.
X. And then I just have to add 0.4 over and I'm done. Right? I don't... So this multiplying by 10 deal or 100 or whatever is an option. You don't have to do it.
What did you get an X? That's what, to 1.2.
Because 1x is x.
Well, yeah, what's 1.2 minus 0.2?
1.
1.0.
So 1.
1x,
X
yes.
is
I like it.
Okay, so I get, so what are you doing? 1.2x.
done.
Multiply that 10.
You could. So you could... I could have taken this problem and multiplied everything by 10. It just looks better. Right? But then I would do all the same steps and I still end up with... Because now I get 10x equals 4. Divided by 10, I'm still going to get 0.4. So I could multiply everything by 10 and change it all to whole numbers, right? I could take this and make it become this, and then solve it. But if I don't have to, I can work with the decimals if I'm cool working with decimals. If you'd rather not work with decimals, you don't have to. You can multiply by whatever you need to move the decimal over enough so there's no more decimals. The trade-off is all your numbers become bigger.
Wait, decimals confusing. But can I go back to 3.3 and question?
All right, so there was, I think what happened after grading the homework, I'm glad you're saying something. There should be no decimals anywhere until you hit chapter 5. But I think in one of these sections, some of the times came out looking like decimals. I can't remember, I think it was in chapter 4 actually, I can't remember. So instead, it looks like 5.9 when it's supposed to be 5 times 9, and it was just the formatting.
It was supposed to be? Okay.
Yes, it was just the formatting on the page that printed out.
It's like, that's definitely a decimal. I don't know.
Exactly. It would have been evil to have decimals in chapter 4, because decimal section is chapter 5. That would be remarkably evil. Even more, too evil for me. But I'm sorry, Jan, what's your question?
220.
In 3.4? What section are we in?
5.3.
5.3. Okay. And you said number, which one?
220.
Oh, this will load someday. What's it say?
3.3 plus 9.
3.3 plus...
No.
Oh, wait, did we...
Yeah, by the last.
Oh, okay.
Wait, it's 3.9.
9. Okay. So, all right. How do you make a fraction into a decimal?
You have to.
What does this bar mean?
Divide.
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 What are you dividing into what?
20 to 9.
Yeah, don't do 9 into 20 because it's smaller and it will fit better. No, you don't have a choice. This says 20 into 9. There, do it. And then add what you get to 3.9. Because currently, can I add a decimal to a fraction? No, I have to make them match up. So you did have a choice. If I just said simplify this and I didn't tell you what to use, you could make this into a fraction like you did. But since this is the decimal chapter, you probably need to make this into a decimal. And this is how you do that in general. Earlier, I showed you a bit of a shortcut since the bottom is such a nice number. You can make the bottom become 100, and then it goes right into decimal. But you just do this. 20 goes into 90 4 times. 20 goes into 100. There, that's 0.45. And then add that to 3.9. 3.9 plus, what is this? That is. Now how do you add those? What do you have to make sure about? Line them up. Line up the decimal points. You put a 0 there if you want to. You leave your friends behind. Because if your friends don't dance.
Okay, so
No friends of mine. What'd you say? Safety drink is yellow.
Yeah. You can add the 0 if you want to. It just makes it easier to see what's going on. Yeah. Yeah, it's a good idea to just do it always. Because if it's a minus, I have to have that there. You know what I mean? If it's a minus, I have to have a 0 there so I know to make it a 10 and borrow and stuff like that. Yeah. How about that debate? Did you watch that?
Grab her mother. I'll put her in jail. I just don't even. I would.
I love you guys.
no,
I didn't watch it.
It's probably the better
I
way
was
to
too
be.
busy living my life.
That's kind of sad.
A loaded question.
We'll find out.
That's so cool.
I don't know.
Yeah, I don't want to. I'm not going to get too deep into that because I do not want to have some kind of riot in here between supporters of various peoples. Somebody in the back going, "Don't forget about the libertarians. What about the Green Party?" Do you know how many candidates there are? Did I already ask you this? Do you know how many candidates there are? There are over 1,000 candidates for President of the United States. Do you know how many political parties there are? There are at least 50 some odd political parties. The Communist Party still is alive and well in this United States. Right?
So what's
Anyway,
the
sir.
percentage of one of those small ones winning?
What's the likelihood? It's a very small number. Yes.
Can you do, it's not that clear.
It's not what? Sorry?
It's not that very clear. I cannot see the steps.
Oh, okay, sure. So there's a little confusion I see from grading the homework, but let me build up to that real quick, Rick. If you saw this, and I said simplify this. All right, let me ask you this: how do you simplify 3 times 4 over 5 times 4? How would you simplify that?
okay,
Don't overthink it.
so
What cancels? The 4s. Are you guys cool with that? You guys see that? Wouldn't the 4s cancel? Because it's the same thing on the top as it is on the bottom. And it's multiplication and division, so those cancel. What's the same on the top and the bottom here?
The lies.
What's y divided by y?
why?
1. They cancel.
Can you keep going? Or
So what's a variable? What is a variable like y? What is it?
X, Y,
What is it? What does it represent?
a one? A number.
A number.
It's a placeholder.
Beautiful.
It's a placeholder.
So anything that numbers do, variables must also do, because variables are numbers. There's numbers I don't know yet, but they are still numbers. So if 4 over 4 would cancel, y over y must also cancel. They cancel each other, right?
So the answer will be just.
In this case, it would be 4 over 9.
And that's it, right?
Now, let's go to the problem. Now this steps it up a bit. Let's start with the easy stuff. Start with the numbers. What can you do with the numbers? Don't even look at the letters. Yeah, the 2 and the 4. Is that cool? And that's it, right? There's no other numbers that'll cancel, right? Now, what letters just directly cancel? What about the W? Cancels. The A's cancel. What does B squared mean? B times B. So one of those B's cancels. So watch. B squared over B is B times B over B. So there's still one B left alive because there were two of them. So one of them kills him, and the other guy is like, oh, I'm still here. Thank God. So now the hardest part sometimes is seeing what the hell's left alive. You don't want to leave anybody out there with the zombies. You want to bring everybody in. So who's left alive on the top? Who's left alive on the top? A 3 and a B. Who's left alive on the bottom? 5 times 2. What did I get? Did I get the right answer? Yeah, I got the right answer. Yes?
I showed B times 3 over 10. Would that work? Or do I
Yeah, but hopefully this looks odd to you guys. Doesn't that look weird? Yes. We write 5x. Yeah. But still, you put the number as the coefficient. Yeah. It's just convention. It's the same answer, but it's just looks more normal. Yeah. What's up?
let it go home instead?
You could do that. You didn't have to come today at all.
I want to cry.
And that's the crazy thing about college is you need some self-responsibility. So you guys are here. I appreciate that. Because that's smart. When you pay for it, hell.